MICROSCOPII B. An ice giant planet. Discovered in 2020. The exoplanet is located nearly 1,150 light-years from Earth and orbits around every 8.4 days. With gravity 26% more than Earth, and radius 0.0645 AU, its mass results in 20 times that of our planet. It takes 8.5 days to complete one orbit around its star. The atmosphere and terrain both hold enormous amounts of sulfur. Particles of gas and dust that the planets are made of are too far away from the core and cannot be combined together by gravity. They remain behind to form the ring system. The primary feature of planet MICROSCOPII B is the rings. They are formed when two moons of the planet move away from within their orbits and eventually crash into each other. When high-energy particles interact with the atmosphere, X-rays through radiation are emitted, produced by energetic electrons after they travel down the planet's magnetic field lines to its poles and are slowed down by the atmosphere. From the satellite views, we can distinguish various topography with different colors shown on the surface. Since the heat on the planet is unimaginably high, the planet absorbs blue light and emits a green color and absorbs yellow and emits red. One part has a green base which is formed through igneous materials that is the result of precipitation of erupted magma. Craters are mainly created by the impact on the solid surface of the planet and also as a result of the flying debris due to the impact. Another fragment is made of a yellow base. As the planet is rich in sulfur, that area is composed of liquid and solid matter that are created through different arrangements and configurations of sulfur. Because of the presence of carbon dioxide, these reactions frequently occur which results in acid precipitation. MICROSCOPII B doesn't have smooth terrain. Rather it has a sloped topography, mainly consisting of large rocks and cliffs. Because of its chemical composition it is resistant to lichens, and thus the green texture on the rocks differs in different landforms. The liquid on the surface is so hot that it causes the formation of ghostly smoked clouds. Because of the sulfur cycle, green and yellow are the dominant colors in the fluid and rocks respectively. Crystallized forms of sulfur can be found on the shoreline. Related to the high temperature, sulfur goes under different reactions which results in changing the color scheme on the rocks near the fluid areas. When we get closer to the outer surface, the presence of flora and fauna are introduced. These are lichen-like platforms that emit radiation, oyster-like flora, and even moss-like textures on rocks. The synonymous element of these organisms are being resilient to high sulfury and acidic conditions. They also have a symbiotic relationship with heat. So, they can maintain their life cycle by having a mutual relation with its environment. Here, we can see the rugged and jaggy texture and overlapping color scheme on the terrain surface. We can also observe that there are deformations due to varying temperatures. The temperature spectrum leads to unique instances of sulfur-based formations reacting with the parent igneous rock to create varying patterns.